the hard way. So anyways, we have an 8 kilogram block that's sliding on a frictionless surface and is moving with an initial velocity of 3 meters per second. And then an impulse is applied to the block, and it's shown in the graph what is the block speed at 6 seconds. So I'll try to sketch this out a little bit. I have a block. Oops, not that size. That's too big. I have a block, and this thing's chucking along at 3 meters per second. It weighs 8 kilograms. Okay. Then I have an impulse that I'm going to apply to it. In the same direction. And then at the end of that, what they really want to know is what is the final velocity. So there's a couple of things, and we just wrote this down again today. Remember that the impulse J is equal to the force times delta T. And that's also equal to the change in momentum, right? Which is really, remember that momentum is just the mass times the velocity. Oops, I forgot to write the T. So what I want to do, if I take these apart, this right here, there's two ways to do this. I could do the change in momentum, which gives me the initial velocity, and the final velocity. I can plug in my 3 meters per second and then calculate the final velocity, and then I could do it that way. But this is easier. I want to just find out what the change in velocity is based on the impulse. Okay, how much velocity, how much of an increase in the velocity would I have? Well, I happen to know that what I know is that the time, I can figure that out. I can figure out the force, because that's in the graph, right? We have the time here and we have the force here. So I got to figure out what that is. I know what the mass is. The mass is 8 kilograms, right? So I'll write that down over here. The mass is equal to 8 kilograms. Now, the time that it takes for this impulse, the impulse occurs in this box right here. And if I want to think of delta t, this is where one of those scenarios where we have the final minus the initial. Well, the final time, TF, is equal to 5 seconds. And then the initial time is 3 seconds. So my delta t is just 5 minus 3. So my impulse is applied over 2 seconds. Now to calculate the force, I just have to figure out how high it is. Well, it's 8 newtons. So what I'm doing is I'm applying a force of 8 newtons. So then my force, because this is over here and it's 8 newtons, is just 8 newtons. So I have the force, the time, the mass, and I'm solving for the velocity. So what I'm going to do is I'm going to take this formula. I want to figure out the velocity, and this is just the velocity increase during the impulse, right? So to find that velocity increase, I'm going to take the force times the time and then divide it by the mass. In other words, I'm going to take 8 newtons and multiply that by 2 seconds and divide by 8 kilograms. And that'll give me my velocity. Well, 8 divided by 8 cancels out, so I really end up with 2 meters per second. So remember, that is the increase in speed. So now to actually calculate the final velocity up here, I'm simply going to take the initial velocity, which was 3, add 2 to it, and that will give me my final velocity of 5 meters per second. Now I could have done the same thing with the mass times the initial velocity times the final velocity minus the initial velocity, all that stuff over here. But then the time is weird. Like it's a little more complicated to set it up. So I'd rather just focus on the impulse. That'll tell me the increase in velocity or decrease, because I could have had a negative number. And then just add or subtract that velocity from the initial velocity. Does that make sense? Okay, that's it for that one.